looking at solubility products. Now this is from page 740 of your textbook, Brown and others, 10th edition. The solubility product is something that's used for characterizing the solubility of marginally soluble salts, meaning things that don't dissolve very much in water. And it is the product of the concentration of the ions involved in equilibrium, each raised to the power of its coefficient in the equilibrium equation, and I quote from the book. So the example we have in one of the problems is barium sulfate. Barium sulfate is used as a radio contrast agent. If you go for an x-ray in your stomach, they give it to you, and it will very effectively shield x-rays because barium is a metal, a fairly heavy metal. It occurs low on the periodic table, that's 56 protons. And it's safe to give in the form of barium sulfate because it's insoluble. It's very insoluble, so it doesn't actually get into your metabolism. It goes through your GI tract and comes out without actually exposing you to barium itself. And they give it to you as a solid suspension, and it'll form a tiny amount of barium ions and a tiny amount of sulfate. The KSP turns out to be the concentration of barium ions times the concentration of sulfate anions, and there's no coefficients there because there's one of each. In practice, example 700 on page 741 from the textbook, barium carbonate undergoes dissociation, and its KSP is given by the concentration of barium ions times the concentration of carbonate anions. And when you multiply those two concentrations together, you get the number 5.0 times 10 to the minus 9. With silver sulfate, because silver is a +1 cation and sulfate is -2, you're going to get 2 silver ions and 1 sulfate. So when you write the KSP equation for silver sulfate, you're going to represent it as this. 1.5 times 10 to the minus 10 is equal to the silver concentration to the power of 2 times the concentration of sulfate. And that number has to equal 1.5 times 10 to the minus 10. The factors that most affect the solubility in these cases are the pH, temperature, and the presence of common ions. When you have, for example, if you have a basic salt that's marginally soluble, for example, like magnesium hydroxide, the presence of acidic conditions will increase the pH. It will decrease the pH, but it will increase the solubility of the substance that is basic. We exploit that fact with milk of magnesia. When you take something to settle your stomach, that white milky substance has a very low solubility in water, but once it gets into your stomach, it dissolves in the presence of the hydrochloric acid to help bring down the pH of your stomach in case you have acid indigestion. Temperature can also increase the solubility of some salts, although temperature increases can also sometimes decrease the solubility of some salts, for example potassium nitrate, and also the presence of common ions. If you have other ions, if there's an ion in solution that would have been released by a certain salt, then it will suppress the formation, it will suppress the ionization of that salt. So for example, if you're trying to dissolve silver sulfate in the solution, the presence of silver ions in the solution will prevent this from happening to the same extent as if it would happen in pure water.